So now we want to have a few objects. We want to spawn these types of characters. And rather than spawn the characters one at a time, what I'm thinking is that we should have a couple of actors that spawn these characters for us. And so the first thing I think is that we should create, well, if you look at like the typical sort of research papers on pathing and navigation, there's two rather large cases that they use. One is a circle, so a bunch of agents crossing a circle, and you'll have seen that in the pathing demo that I showed you. Or you can look on my YouTube channel and see that sort of Unreal Engine navigation demo that I put up. So you have a crossing circle where people spawn on a sort of large circle and then go through the center and to the opposite side. Or you have a bunch of agents trying to cross around each other. And because we're trying to have a look at the navigation properties of the Unreal Engine, we probably want to do both of those cases. So let's start with a new blueprint class. It's just going to be an actor. And let's call this circle owner. So our circle spawner, oh, there's one thing. So we've got the scene root, and what we probably want to do is we want to add a capsule. I don't remember where it's, was it capsule? Yeah, okay. We're going to call this capsule. And the reason why I want to do this is that we actually want to get the location of this object and make things relative to it. And if we have the capsule, we can get the capsule from the object and actually have it the same size as our character. So if we look at our nav character, there's a capsule on him. So if we get the same proportions of capsule size, so capsule component, get rid of that. Yep, so the capsule shape, capsule half height 96 and 42. Go to our circle spawner and have the capsule and 96 and 42. I know this is going to look a tad strange, but what we want is the capsule essentially to sit on the ground the same way a character would. So it means that when we get the center of this thing, it'll be at the same height as the center of the character. Yeah, so we don't have to worry about we don't have to worry about movement in the vertical plane. So when we're getting the position of this thing, we're actually getting the position of the capsule and not the position of the bottom. What I'm saying really is that I like that, having that available. So let's have a look at the event graph for this guy. What we're going to do is we're going to do something on begin play. So let's just move these two other guys out of the way. And let's think of what we want to do. We want to be able to say that we're spawning n number of actors. So we probably want some kind of count variable. And we're going to spawn them on a circle around a center point. Now our center point can obviously be the center of us. So there are a few things that we need to add in terms of variables. So let's just add the spawn count, and let's make sure that that's set to integer. make sure you compile and save these things, and this default, let's go for 10, say. Now what else do we need? We need, let's make sure that all of these things are visible. You need a radius, so let's call that radius, and that's going to be a float. And again, save, compile, and you get the default value. And let's go for 300 or something. So what you're looking for, oh, don't forget to make sure that that's public. And we're going to set that in the editor anyway, so that's not so much of a problem. The next one we want is we want another variable, and that is current angle. And again, it's a float, so it defaults to what the last thing you added was, so we'll use that. Save and compile. Current angle is 0, which is good. So the final one we want for now is we want the type of thing to spawn. So let's add a variable. Now this time it's got to be a class. So oops, I selected the wrong type there, isn't it? Object type, I think it's in there somewhere. Let's use the character. Oop, no, that's a character reference. We want the character class. So somewhere in there. Okay, so it actually allows us to do it from there. That's new. Interesting. So character, go for character, and we want class. So you'll see it basically comes up as purple. So we want to say character class, and the class is the Unreal Engine class type. So basically we'll be able to say whatever type of character we want to spawn in this thing, and we're using this because there's actually going to be 2 different types of characters at the end. Default value capsule component, kind of weird. Oh, why has it done that? It's gone to that. That is very weird. Character class. Okay, just make sure it selects character class, will you? So, purple variable character. Save and compile. Make sure that's public as well. And then we need to actually do the code for it all. So we'll do that in the next video. Okay, let's get on with the actual code now then. So we're going to do a for loop. And our first index is 1. And our second index is our spawn count. We're basically doing a loop through the number of spawn objects. And we're going to call spawn actor. Spawn actor. And it's spawn actor from class. Now, what we can do is we can say, so the class is going to be our character class that we input. Collision handling, always spawn ignores collisions is probably the best one, I think. We're going to create a transform for the object, so we need to calculate that. Is there anything else we need? No, that should do us. Okay, so what we want to do is we want to calculate where on the circle the guy is going to spawn. And for that, what we need is a little bit of maths code to sort of, I guess, calculate the angle based on the index of the guy who's going to spawn. Let's just drag this guy off here and convert to float, because we're going to multiply that. So just type the multiply. We're going to float multiply by float. And for our input, what we want is we want to divide 360 degrees. So let's just do float divide. We're going to divide 360 degrees, so 360, by our spawn count as a float. Multiply those two together, and then we're going to say, okay, our current angle, add and then that is going to make the rotation for a vector. So we go make rot, and what we're going to do is we're going to feed that into the yaw of this rotator. Now we can leave those other two as zeros. We want to make rotate, and then we're going to rotate vector. And the rotation vector we're going to do is basically just a single value. So we're going to do make vector. I'm going to drag the radius into the end. Drag that. Radius in X value. So that will essentially give us a rotated unit vector in the x-axis, rotated by the angle of the guy we're going to spawn. We're then going to get the capsule, going to get world location. For that, going to add the rotation vector onto it. So if you can see what it's doing, it's basically creating the point that we're going to use as a transform spawning. Let's just drag this guy over here a bit, and we're going to go make transform. We're going to use that as a spawn transform. So let's just tidy this stuff up a tad. So what we're essentially doing is, for each loop through the for loop, we're getting the index of the guy we're spawning. So we're going to spawn from 1 to spawn count objects. We're saying, okay, so the first one, we're going to divide 360 up by our spawn count, and we're going to multiply the, we're going to essentially add however much that angle is onto our current angle to make a rotator. That rotator is going to rotate a unit vector, which is as big as our radius, And we're going to add that vector onto our current location of the spawning object. So what that means is it's going to create points on a circle relative to the location of the capsule, based on the index of the thing to be spawned. Once we've done that, we can actually spawn the actor, and that should create the guys on the circle. So let's test that one out. Let's just get rid of this guy and create a circle spawner. You can see why I added that, and let's just go to the circle spawner. Character class will say a nav character. I didn't make the thing visible, did I? Yes, I did. Spawn count. Where's spawn count? There. Okay, so we're going to spawn 10 of these nav guys. Okie dokie. Something went slightly wrong there, but it certainly tried to spawn them. I think I might have missed a little bit on the here. I've made the rotator. What's oh, that's why it's not a rotator that we want. It's actually make rot. Make rotation from axes? Nope. Make rot. That's kind of strange, really. Wonder if the rot even a space. Yeah, that's strange. No, that should do it. How about I divide the spawn count? It would be I wonder if the order of these has changed a little bit. Because normally it used to be pitch your roll. So yeah, that is strange. I think something's changed with the version of Unreal Engine using here. Let's see. Oh, there you go. So the idea is that if we want to, we can say, okay, let's spawn. That was 300, so let's give it 2,000. Let's do 100 guys. A little bit. Do that. Okay, so we're spawning the guys. Now all we need to do is we need to set their target locations, really. Because, you know, it's exposed on the things. So let's have a think what we can do here. We can we've got the current angles and that kind of thing. So all we need to do really is, well, there's a few things we want to do. We want to take whatever we spawned, we want to set its target location. Now, what is the target location? Well, think about it. We've got a vector here, or rather here, that is calculating like the point on a circle. So what we actually want is the opposite direction of the offset from that circle center. So we've made that rotation. We've added it to the world center. What we can do is we can take this value. So this is the sort of rotated value. We can negate it. So see if there is a negate. Yep, there is. Negate vector. We can then do the same as we did here, which is get the world location and add it. And then we can take the object that was spawned and we can cast to AI nav character. And then we can set target location. So if the cast works, set the target location to the negated vector from the start location. So basically, we start them on the edge of a circle and we give it the destination of the opposite edge of the circle. So let's just go through the nodes again just to make sure it's clear. On the begin play, we're going to do a for loop. We've got a spawn count variable, it's an integer. We're going to loop through for that number of spawns. We're going to call spawn actor, actually spawn actor from class. We're going to pass in the character class that we set up as a variable for input, and we're going to spawn it. And then we're going to calculate the spawn transform by doing a make transform. We're going to take the center of this object. So this is the sort of circle spawner. We're going to take the center of that and get its world location. We're going to add essentially the offset from that for loop. So by dividing 360 degrees, which is the full circle, divided by the number of guys we're going to spawn on it, multiply that by the index. So basically this divides the whole circle up into n number of slots, so spawn count number of slots, multiplied by the current index, so we get the angle that we want. Add that to 0 basically. We could actually do away with that and not even add it at all, I guess. Make a rotation out of that. So the rotator rotates a unit vector in the x, and that rotation gets added to the center point of where we want to start from and makes the transform for where we're going to spawn. It also gets the rotation for the thing we're going to, like the sort of offset from the center that we're going to do. It negates it, so it goes in the opposite direction, and then adds that to the world center again to get the opposite side of the circle, and we set that as the target location. So that's a bit of a mouthful, but let's see how it works. Try it, and all of the characters kind of try and move to get there. And then what you'll find is that none of them actually get to where they're supposed to be going, which is good. This is what we want. So we've got our circle spawner. Now the question is, why did none of them get there? Well, it's because none of them have got any kind of avoidance on them at all. They just hit something and stop, which is kind of the point of this. So if you go into your character, one of the properties you'll find somewhere in here should be. Oh, it's on the movement component. You click on the nav character itself. If you go to RVO, one of the things somewhere in here. Maybe it's on the. Yeah, okay. It'll be on the then. Oh, the other thing is we want to make sure that we've got this controller transform attached to the pawn when we create it. That's quite important. So where is the RVO set? Sure it was on the character. Oh, it's on the character movement component, that's why. So on the character movement component, there's a load of stuff, but if we type in RVO, it allows us in the avoidance section to switch on RVO avoidance. And RVO stands for reciprocal velocity obstacles. And the RVO implementation, or the RVO approach, comes from a guy called Joe van der Berg. I think it's Joe van der Berg, and his mate Stephen Guy. And they calculated a sort of geometric version of obstacle avoidance. So with that checked, we should see that the guys actually do a little bit of kind of steering away from each other. Now there's a whole bunch of properties you can tweak to make this kind of thing work. What you'll find is that in this circumstance, most of these guys eventually will get to their target location. And obviously we can tweak the RVO avoidance stuff. There's actually a bunch of objects, a bunch of settings that I'll show you in a second, which will allow us to tweak those different things. But it's not ideal. I think we can all agree that the RVO is a little bit sort of weird. Just to show you where that goes, I think it's project settings and AI system, is it? Or is it? No, it's crowd. Crowd. So these elements here, I can't remember which way around it is. I think this is for the detour thing, and where are we? Okay, it's definitely not. It must be the crowd one. No, the crowd settings, definitely not the RVO settings. Let's just see if it's inside. Characters. So let's just get rid of that and go to the avoidance. Oh, there we go. So you can actually like tweak the values here. Let's just see. Oh yeah, you can group them by sort of groups of people to ignore and all that kind of stuff. But frankly, I'm not so sure I like this version of it. Let's give it a 0.5 weight, because it's supposed to be that by default, but it wasn't. Avoidance consideration. You know, you can tweak these values and see what they do. So make sure to save. So you'll get different properties. The thing I don't like is that you see them sliding around, and that's really not very useful for crowds. So the RVO is one option, and eventually they should kind of get there. You can make it easier for them by, changing the size of how far they're going to look ahead. So if we go back to that character, see if they actually get in place first. So for the most part, it makes it so that they don't just log jam straight up. But you get a little bit of this kind of pushing and going around and circling and all. Not ideal. So we can make it easier for them. Going back to the avoidance stuff, we can just sort of avoid really close in things. Let's do 200. That helps. So that avoidance value is essentially how far away it looks to try and avoid the objects. So anything over 200 is ignore essentially. And obviously you can tweak these things a little bit, and eventually this kind of thing will sort of work out. It's kind of, that value is kind of saying how localized the avoidance is. See, have mesh view off. Oh, you see this guy can't quite get there. There you go. So you see it's all kind of, why is P not working? Yeah. So that's a circle spawner. That's not so bad as a start. Let's now think about, okay, we want to do the same kind of thing. We want to do a grid spawner. So we want to spawn n number of characters on a grid. So let's have a quick break there, and we'll do that in the next part.